So in this last example, we are going to use the idea of what we've learned with terminal sides of angles and find the distance from the origin to some point which is given to us as 4, -4. So what I have here is a graph, and I'm going to plot the point 4, -4 on the graph. So 4, -4 would be over here, about right there. That's the point 4, -4. And if I want to know what the distance is from the origin to that point, then I'm going to draw my line. Now, we are going to use in this course a whole lot the idea of Pythagorean's theorem. Remember that Pythagorean's theorem told us that if I have a right triangle, if I know a squared plus b squared, I can find c squared. Well, we have that here in drawing this picture. I know that one of the sides of my triangle would be 4 because I moved over 4 in the x direction. I know another side of my triangle has a distance or a length of 4 as well. And it's ultimately this value right here, the length, distance from the origin to this point that I'm going to be finding. So Pythagorean's theorem, remember, says if I have a squared plus b squared, that equals c squared, where the a's and the b's are the sides of my triangle. So coming back in and replacing that with 4 squared plus 4 squared equals c squared. So this would be 16 plus 16, which is 32, is equal to c squared. And in order to solve for a c squared, I've got to take the square root of both sides. And the square root of 32, the square root of 32 is going to be 4 square roots of 2. That gives me c. So I know then, not just c, but that's really r. I know then that the distance of r from the origin to this point here is 4 square roots of 2. Now, just as kind of a side, if you don't remember how to simplify the square root of 32 and get 4 square roots of 2, we will be doing a lot of simplifying radicals in this course as well. So when I'm talking about simplifying this, I'm going to look for perfect square factors of 32. Perfect square factors of 32. Well, that's going to be 16 times 2, right? There's a 16 times 2. And it just so happens, because I chose it this way, that the square root of 16 is a perfect square. Okay, so I can rewrite it like this. Technically, this is what I'm doing, separating out my two terms here. And when I take the square root of 16, I get 4 times the square root of 2. Now, normally when we take the square root of a value, we get the plus or minus of that term. But because I'm looking at the distance here, I'm only interested in the positive 4 square roots of 2. So again, to simplify a radical, you look for the perfect square factors of 32, and that was 16, because 16 is a perfect square, times 2, and I end up with 4 square roots of 2. So that's how we know what the distance is of r.